Hi, I'm Adolph Oliver, and this is a video clip on solving rational equations. Now, equations, of course, have two sides, and that means we can solve them. We know that's the standard thing in equations. But now, rational equations means that they also have fractions in them. Well, we've solved such equations in the past, but all the ones that we did in the past were like this guy right here, no variables downstairs. And what we did was multiply through by the LCD. Let's see, I think it'd be 15 here, and clear out the fractions, and then that made the rest of the problem much easier to solve. Well, the twist now is the following. Okay, now we have equations that do have variables in the denominators. Here's a simple example right here. Well, we're going to do the same thing. We're going to figure out what the LCD is. Looks like it's 4 times P here, and multiply each and every term by that and cancel out the denominators. But there's one additional problem that we have to keep track of here. A little bit more work in these, because there could be some values of the variable which make the downstairs equal to 0. For instance, right here, P equals 0. This denominator would be 0. Same thing right here. Well, anytime the downstairs of a fraction is 0, the fraction is undefined. Or we say it equals infinity, meaning the same thing. Well, that kills off all of the math operations, because just look at the example here. If this guy's infinity, anything we add to infinity, we still got infinity. There's no change. In fact, if you subtract, multiply, or divide against anything that's infinity, there's no change, and if there's no change, there's no way you can solve the equation. So here's what we're going to do. Okay, we're going to have to keep track of any possible values of the denominator which can make any of the terms 0. And we have to disallow those terms. And if they turn out to be something that are possible answers, we have to toss them out. We have to discard them. So that's our process here. What we're going to do is use techniques we're familiar with, but a couple extra steps. One, we'll have to make a list of bad values, and then when we finish up, see if any of our answers match any of those bad ones, and in which case we'll toss them out. So, not particularly difficult to do. We've learned most of these techniques already. Let's just show you now what happens as we work on this. Okay, here we go. A first simple example. This is an equation. It's got fractions in it, but now we notice there are some variables downstairs. Now, this first term over here doesn't have a fraction, so what I'm going to do is an old trick that we've learned from the past. Make a fraction out of it by putting a 1 underneath, and that just reminds us that we have to treat it all the same way. Okay, here we go. Well, the LCD here is simply going to be R. Okay, and now I'm going to multiply each and every term by this LCD. Remember, you can multiply an equation through by any variable, or any number. You can also multiply it through or divide through by anything too. But you have to make sure that you treat each term the same. When I multiply through by this LCD, which equals R, I've got to hit each term once and only once on both sides. I like to be very deliberate about this. So here's what I normally do. I'm going to put the R up here, okay, and R up here as well, and R up here as well. That's the LCD. All I'm doing is reminding myself that I'm multiplying each of these terms by R. Now, if this is the correct LCD, it'll take out all the denominators. We can reduce it. R goes once here, and this R goes once. Same thing here, R goes once, and this R goes once. Now notice, this guy in front already had a 1 downstairs, so the full R remains. Okay, we had to, of course, multiply him by R because it's a balance scale thing. We got to treat each term the same. Now, the denominators are all 1, so the answers are just the upstairs. Go back and put the leftovers together. 1 times R is R. Okay, I'll just write it as R. You could put a plus 1 in front if you wanted. Plus 1 times 1 is plus 1 equals 1 times 4, which is 4. Now, here's one thing we should have done right off the bat. I was a little slow in doing it here. And that was we needed to make a bad list. Okay. And that's the values of the variable that we will not allow. Well, remember, what value of R would make these downstairs guys equal to 0? R equals 0. So if 0 came up as an answer in this equation, we'd have to toss it out. This first guy over here has a 1 downstairs. He's never going to equal 0, so we don't have to worry about him. Okay, well, let's get back to our equation here. This is a very simple one, nice little linear equation once we clean it up. Plus 1 comes over as negative 1, so I end up with R equals 3. Now, the first thing you do is you go back up and check this against the bad list to see if it's one of the bad values. Well, R equals 3 is not in the bad list, so that means that this is a good answer. Well, that's all there is, the extra stuff. Making the bad list and checking it at the tail end. Everything else is standard solving equations with fractions that we've had practice in before. Okay, here's another one coming up. Let's do the bad list right to begin with, like we should. You have to have all the denominators factored. Notice these are all single terms. So our bad list here is going to look just like it was from the first guy. The only value that's going to make any of these denominators 0 is if p equals 0. So we will not allow p equals 0 if it shows up as an answer. Now, the next thing we do is look at the LCD. Well, we got p squareds here, p here, so the LCD is going to equal p squared. Now I'm going to multiply each and every term by this p squared. Again, be very careful you don't goof this up. That's why I do this type of process, because then I can double check it real well. Notice I've hit each term, the one on the left, the two on the right, by p squared. So I'm treating everybody the same. Okay, now one other thing here. There is one numerator here which has more than a single term, the p plus 6. Put parens around that just to remind yourself that that's the entire numerator, and anything that might be left over there has to multiply this whole numerator. Well, okay, now, if this again is the correct LCD, we'll be able to go through and cancel out all the denominators against it. So p goes once here, and the p squared, it leaves me a single p. P squared goes once here, it goes once up here. P squared goes once here, it goes once up here. Okay, well, notice all of our denominators are gone, so our LCD was good. Now put the leftovers together. 2 times p equals, okay, what do we got here? 1 times, I'll write it all out in its full glory here. 1 times p plus 6, and then minus 1 times 1 is negative 1. Okay, well, this looks like a linear equation once again. Let's go ahead and clean it up a little further. On the left, it's as clean as you can get here. 2p equals, now, of course, we distribute the 1 in. Well, 1 is not going to change anything. 1 times p is p. 1 times plus 6 is plus 6. And then, of course, don't forget we have the minus 1. Okay, well, we're getting closer here. I still have the 2p on the left. A single p on the right, plus 6 minus 1 is plus 5. Okay, well now, I want to solve for p, so I got to get the p's all to the left. So this plus p comes over as negative p. 2p minus p gives me a single p equals, looks like it's 5. Now, again, check that against the bad list way up on top. Our bad list was just x equals, or p equals 0, and p equals 5 is not 0, so here we are. That's a good solution. Now, you have to keep checking these guys. Most of the time, the solutions will be good. But you will bump into cases where that's not true, and you'll have to toss out the solution. Okay, here we go. Again, we've got an equation. We solve for the variable. We notice there's variables downstairs. So that means we're going to have to make ourselves a bad list to remind us of values we will not allow as answers. Now, first thing we got to do, factor the downstairs into single terms. So the only thing I can do with x plus 6, in fact, to both of them, is to put parens around it because there was no GCF or anything else we could do. So there it is, single terms. Now, remember, this guy in the end, good idea to put a 1 underneath so you remember that it also has to be hit. The biggest mistake folks make is when they go through and multiply by the LCD, they forget to do anybody that's a plain whole number, and that throws the balance off. That's not correct. Well, anyway, the LCD here is simply going to be our x plus 6, okay? So that means now what I'm going to do is multiply each and every term on both sides by x plus 6. Here we go. X plus 6 here, x plus 6 here, and x plus 6 here. Okay, well, let's go back now and cancel out the denominators. X plus 6 goes once here, goes once up here. First guy on the right, x plus 6 once here, once here. Notice the second guy already at 1, so the full x plus 6 stays. Okay, now let's go put all the leftovers together. Whoops. Let's do one thing here. Forgot again the bad list. Okay. Now, look at this carefully. X plus 6. What value of x will make this 0? Well, what do you have to combine with plus 6 to make 0? Negative 6. So the bad list here equals negative 6. You can have more than one value in your bad list. So far, we've only had one. This one here is the same thing, negative 6. So if negative 6 shows up as an answer, we'll have to toss it out and say that there are no answers. Okay, let's put our leftovers together. 2 times 1 is 2, equals 1 times 1, which is 1, plus 1 times the x plus 6. Okay, here we go. Let's clean up the right. The left is okay here. It's just simply 2. The 1 is okay in front, but the plus 1 has to be distributed in. So I get plus 1x, and plus 1 times plus 6 is plus 6. Okay, well, clean it up a little bit further. Combine those plain numbers. 2 equals, let's see, this is officially a plus 1 and a plus 6. So I'll make it 7 plus x. You could keep the 1 there, or since it's only a 1, you can drop it off. Now, we want to solve this thing. Notice I'm solving for x and it's on the wrong side. If I take and jump this x over by itself, it'll come over as negative x, and then I've got a problem with that minus sign. So this is the old classic case here where what I'm going to do instead, since I got the sign I want on the x, I'm just going to interchange the two sides exactly like they are. Now remember this. When you ever interchange the sides all at once, okay, you do not change the signs. It's like you're taking the two pans in a balance scale and just swapping the pans. The only time you change the signs is when you jump a term by itself. And of course, that's what we're going to do right now. Officially, this 7 has a plus in front of it. We need to get rid of it, so it comes over here as negative 7. So I end up with x equals, what's it going to be? Looks like it's going to be 2 minus 7. Looks like it's going to be minus 5. Okay, once again, we go up and check our bad list. Almost got ourselves in trouble up here. Remember, the bad list had negative 6 in it. That would be what we disallowed. Negative 5, however, we're good. Okay, so nothing to discard there. Okay, here we go. Let's take a look at one last of these guys. Some of these guys, of course, we're going to have to do a little bit of factoring to be able to figure out what the LCD is and everything else, the bad list as well. Notice this again. We've got an equation, so we know we're solving for the variable. We got fractions, so we're going to have to clean them up, but they're variables downstairs. So here we go. Let's see if we can factor this. Again, it looks like a good old reverse FOIL. Okay, remember, here's the idea. We want two numbers multiplied together. Give me 18, whose difference is 3. In other words, if you remember how to do this, two numbers give you 18. The minus here means we want difference. If it had been a plus, we'd want sum. So the difference is 3. Well, okay, looks like it's 6 and 3, I think, isn't it? And since the last term is negative here, the signs are going to be one of each. So you may remember the bigger game. The two numbers we have here are 6 and 3. The bigger guy has to have the sign of the center term. These are all the little tricks that you have to be able to do this reverse FOIL factoring. So what do we end up with down here? Well, we got the 5 on top, and it's going to be m plus 6, okay, times m minus 3. Now let's double check that to make sure that it's correct. Okay, if we multiply this back out, FOIL it. First times first, m times m is m squared. Last times last, plus 6 times negative 3 is negative 18. If we do the two rainbows on here, remember, the big rainbow is negative 3m. The little rainbow is plus 6m. Okay, plus 6m minus 3m plus 3m. Okay, our factoring is good. Now, let's continue on the right side. Notice here, all we can do with the m plus 6 is put parens around it. There's nothing else that we can factor out of it, so there it is. The 4 remains upstairs. Now, this last guy, we got a little gift here. We got the 6 upstairs, but notice the downstairs happens to be the same as the first fraction on the left over here. So we know that this factors into m plus 6 times m minus 3. Okay, well now, here we go. Let's figure out first what the bad list is. I got a little bit of room right here, so I'll put it in here. Bad list equals. Okay, see the first fraction? A negative 6 would make this 0. The whole thing would be 0. And a positive 3 would do the same. So negative 6 and positive 3 are two bad values. I'll put a plus in front of 3 to rub it in. The first guy on the right, negative 6, is a duplicate, so we don't have to write it down. And the second guy gives us the negative 6 and plus 3 again. Okay, there's our bad list. Now, the next thing we need to do is figure out what the LCD is. Remember, how you come up with this when you've got everything factored is you write all the different factors that you bump into in all the denominators. So I've got m plus 6. Okay, m minus 3 is not in the list. I put it in. Let's see what we got here. M plus 6 is a duplicate. We don't put any duplicates, only new ones. And m plus 6 here is a duplicate, and the m minus 3 is a duplicate. Now, the only other thing we do is go back and take the highest power we see of any of these guys. And since everybody's to the first power, there's our LCD. So what this means now is that we've got to convert all of these fractions to the LCD. Actually, we're not going to convert them to the LCD. Remember, since this is an equation, we want to get rid of them. So here we go. We're going to multiply m plus 6 times m minus 3. There it is, first term on the left, first term on the right. M plus 6 times m minus 3. And the second term, m plus 6 times m minus 3. Okay, I've multiplied each and every term on both sides once and only once by what the LCD was. Now, let's take out the denominators. M plus 6 goes once here and once here. Okay, M minus 3 once here and once there. Over on the right, the M plus 6 takes each other out. This is 1 and this is 1. And again, in the end, the M plus 6's and the M minus 3's take each other out. So most everybody gets canceled out here. Let's now go back and put the leftovers together. Okay, here we go. Notice, of course, that we just got ones downstairs, so the answers are just the upstairs. Upstairs here, I got 5 times 1 times 1. Well, that's just 5. Equals on the right, 4 times M minus 3. So here we go. We'll clean this up in a moment. 4 times M minus 3. And then plus 6 times 1 is plus 6. Okay, let's keep going and see what we've got here. Okay, 5 equals, distribute to 4n. I get 4m minus 12 plus 6. Now let's double check this. 4 times m, 4m, 4 times minus 3 minus 12. Okay, let's combine these last two guys. Again, I've got 5 equals 4m minus 12 plus 6 should be minus 6. Okay, well, once again, what I'm going to do here, since I've got a plus in front of my 4m, I don't want to jump it over by itself. It'll make it negative 4m, and then I'll have to clean up the negative. I'm just going to interchange the sides. 4m minus 6 equals 5. Okay, now take the minus 6 and jump it to the right. Remember, now we jump a single term. Now the sign does change. So I end up with 4m equals, let's see what we got here. 5 plus 6 looks like 11. Well, okay, the last thing to do here is turn around and divide both sides by 4. Okay, we can't reduce this any. No need to make a mixed number out of it. We can just leave it as a fraction. So m equals 11/4 is what we've got. Now, once again, go back upstairs and check this against the bad list. Looks like we're good again. The bad list had -6 and +3. Our m equals 11/4. It's good. Okay, well then, thing you have to watch out for now, when you have equations that have fractions in them, if there's a variable downstairs, then you've got to make a bad list, and you have to factor to do that. The factoring also is used to find the LCD. Then, of course, you multiply through by the LCD and solve the equation. Okay, it could be linear, like the ones we've looked at here. It could be quadratic also. If there are any answers that happen to be in the bad list, then you have to discard them. If this m 11/4 would have been in the bad list, we would have disallowed it and simply said no solutions left. Then we had one, it was no good, so there's no solution.